All right, so this is going to be a code lab on testing in Jetpack Compose. So I'm on the Google Code Labs website. I filtered by Android, searched for test, and it's this one, testing in Jetpack Compose. I'm gonna click that. All right, here we go. Let's get started. All right, in this code lab, you'll learn about testing UIs. You'll create your first tests. Learning about testing in isolation, debugging tests, semantics, trees, and synchronization. All right, you'll need Android Studio Bumblebee. I did just update Android Studio. Kotlin, I got that. Basic understanding of Compose, got that. Modifiers, I know that. And I took this already. All right, check out the code for this code lab. You're going to use the Rally Material Study as the base for this code lab. You'll find it right here. So I'm going to grab this URL, just the URL. All right, and I'm going to open up Android Studio. Okay, so open Android Studio. I'm going to do get from VCS, version control system, paste that URL. It's going to load it. Clone. All right, it's opening that up. And then once downloaded, it says open the testing code lab project. So once I get it, then I got to go into here, file, open. And I want to select testing code lab, this one. So select testing code lab, do open. I'm going to do it in this window. Okay. All right. And then there's two branches. Looks like starting point and solution. I'm going to change this to project. Open this up. Okay. Okay, contains some stuff. Let's see, repo starter code for all code labs in this pathway. For this code lab, we're using that one. I got that open. The project is built in multiple Git branches, main and end. So end is the solution, main is where you start. Let's make sure we're on main, which we are. Cool. Okay, examine the project structure. Compose tests are instrumented tests. This means they require a device, physical device, or emulator to run on. Rally already contains some instrumented UI tests. You can find them in Android test source set. All right. Let's look at that. Let me change that back to project, app, source, Android test. Okay, so here is the test. Awesome. All right, this is the directory where you'll place the new tests. Feel free to take a look at animating circle tests file to learn what a compose test looks like. Rally is already configured, but all you need to enable compose tests in a new project is the testing dependencies in the build Gradle file of the relevant module, which are, all right, so let's open that up. Let's have a look. All right, so one is JUnit for Android test implementation, which is right here. And the other is a debug implementation for UI test manifest, which is right here. Okay. Note, for more information about how to set up testing in your Compose app, check out testing documentation. Feel free to run the app and familiarize yourself with it. I'm going to go to next. All right, what to test? We're going to focus on Rally's tab bar, which contains a row of tabs, overview, accounts, and bills. It looks like this in context. Let's run it and just have a look real quick. All right, I'm going to specify the embedded JDK, apply that, and then I'm going to run it. And it looks like in the new Android Studio, the emulator runs in Android Studio rather than a separate window, which is kind of cool. So all your controls are right here. That's new. All right, launching activity. Let's see. All right, so very cool. So it's like an overview screen, account screen, bills screen. Yeah. Okay, so those are like the three things: overview, accounts, and bills. All right, very nice. All right, next one. I wonder if I could just close. Yeah, as he. Okay. All right, in this code lab, you'll test the UI, the app of the bar. This could mean many things. Test that the tabs show the intended icon and text. Test that the animation matches the spec. Test that the triggered navigation events are correct. Test the placement and distances of the UI elements in different states. Take a screenshot of the app bar and compare it with the previous screenshot. Oh, that's interesting. You can basically take screenshots and then compare that output file, that photo. I don't know if it's a JPEG or a PNG, or it just compares bitmaps. I'm not sure. All right, see, there are no exact rules about how much or how to test a component. You could do all of the above. In this codelab, you're going to test that the state logic is correct by verifying that a tab shows its label only when it is selected. The active screen defines the tab that is selected. Okay, next. All right, create a simple UI test. Create the top app bar test file. Create a new file in the same folder as animating circle tests and call it top app bar test. I'm going to copy that name. I'm going to make that file. It goes right here. I'm going to call it that. Add that. Okay, so that's where this new test goes. Compose comes with a compose test rule. You can obtain it by calling create compose rule. This rule lets you set the compose content under test and interact with it. Okay, so let's grab this. Okay, we just got the rule. Create compose rule, awesome. All right, testing in isolation. In a compose test, we can start the app's main activity similarly to how you would do it in the Android view world using Espresso. For example, you can do this with create Android compose rule. It says don't copy this over, but that's how you would create a rule to start the rally activity. However, with Compose, we can simplify things considerably by testing a component in isolation. You can choose what Compose UI content to use in the test. This is done with the set content method of the Compose test rule, and you can call it anywhere, but just once. All right, so this is the test. import that. Which one do we import here? I believe it's not the top one. It's going to be one of these other ones. I'm going to say the first one, or the second one, this one. All right, it says, okay. We want to test the top app bar, so let's focus on that. Call rally top app bar inside set content and let Android Studio complete the names of the parameters. Okay. So this is inside our test. Rally top. Oh, wait, no. This is a whole test. We'll grab the whole test and replace it with this. Okay, we gotta call that rally. Okay. The importance of a testable composable. Rally top app bar takes 3 parameters that are easy to provide so we can pass fake data that we control. For example, okay, so we want to pass in all screens, an empty function, and then rally screen.accounts. Okay, this is all screens. Why is that not like, oh, we need to get this oops. We got to get this variable right here. And then we got an empty function, and then we got, what was it was like rally screen.accounts. What is this? Let's have a look, see what this is. Oh, it's an enum. Okay, and these enums, they have an icon and a body, a composable body. Okay, on screen changed. That's the body, account body. That's a function that takes a list of accounts. Bills body. It's a function, a composable function, and it has bills, a list of bill objects. Okay. All right. Oh, and then we want the thread to sleep for 5,000 milliseconds after this. Okay, let's see. We also add a sleep so that you can see what's going on. Right click on Rally Top App Bar Test, click Run Rally Top App Bar Test. So we want to run this test. I'm just going to click this. The emulator was not started, so let me click Run again. Now that it's started. Okay. All right. Says the launch succeeded, but it's still building. All right, looks like it's going. There we go. Now it's running. Let's see. So it launches that app bar and then sleeps for, and it does it with accounts and then goes to sleep. Or it sleeps there on that thread for 5 seconds. All right. I don't believe there was an assertion made though. It just set the content. So, all right, let's keep going. All right, the test shows the top app bar for 5 seconds, but it doesn't look as we expected. It has a light theme. The reason is that the bar is built using material components which expect to be within a material theme. Else they fall into a baseline styles colors. Material theme has good defaults so it doesn't crash. Since we're not going to test the theme or take screenshots, we can omit it and work with the default light theme. Feel free to wrap Rally top app bar with Rally theme to fix it. Does it show us how to do that, or we just gotta know? Let's see. It says feel free to wrap it with Rally theme. Let's see. I believe that's how you do it. Let's run it. Let's run it again and see if that changes the theme. Yeah, I think that changed it. Yeah. Cool. Excellent. All right, so, okay, verify that the tab is selected. Finding UI elements, checking their properties, and performing actions is done through the test rule following this pattern. You got the compose test rule, you got a finder, an assertion, and an action. In this test, you look for the word accounts to verify that the label for the selected tab is shown. Okay, a good way to understand what tools are available is using the Compose testing cheat sheet. We're going to look at that. Or the test package reference documentation. Look for finders and assertions that might help in our situation. For example, on node with text, on node with content description is selected, has content description, assert is selected. Each tab has a different content description, overview, accounts, bills. Knowing this, replace the thread sleep with the statement that looks for a content description and asserts that it exists. Okay, so we're changing this. Okay, so the name of our function is now this. Our test is now this. Rally top bar test. Rename usages. Okay. Let's see. We got that, and now we need this. So this is where the actual testing happens. We get rid of that sleep. We got to import these extension functions. All right. Let's see what else. Now run the test again, and you should see a green test. We saw a green one before, but there was no assertion, so let's see. So this compose test rule says on node with content description, accounts.name. What is this? This is a string, I believe. Okay. Assert is selected. Is there a default value for this name? Oh, it's just enum, so accounts the name. Is there a default name for, maybe it just uses that as the name, the actual name of the enum. I believe that makes sense. Let me double check that. Returns the name of this enum constant exactly as it's declared in its enum declaration. So that's how it works. All right, that test passed. Awesome. All right, congratulations. You've written your first Compose test. You've learned how to test in isolation and how to use finders and assertions. This was straightforward but required some previous knowledge about the component, the content descriptions, and the selected property. You'll learn how to inspect what properties are available in the next step. Cool. All right, next step. In this step, you'll verify that the label of the current tab is displayed in uppercase. Okay? A possible solution would be to try to find the text and assert that it exists. So right here, we'll grab that. Wait, is this a different test or a new one? Current label exists. Okay, so this is a new one. Let's grab it. Let's make a new one here. On node with text. So that's a new. Okay, on node with text. We took the name of it, put it all in uppercase, and we got to assert that it exists. And it says this should fail. Let's check that out. In this step, you learn how to debug this using the semantics tree. All right, I'm not familiar with semantics tree. Okay, see, assert failed, assert exists. All right, so that assertion failed. Reason expected exactly one node, but could not find any one node that satisfies text plus editable text accounts. Editable text contains accounts. Ignore case false. However, the unmerged tree contains one node that matches. Are you missing used unmerged node equals true in your finder? I don't know. I'm not exactly sure. Maybe I am. Is that an option here? Dot use. No. Or do we add it here? Use. So our finder, I believe this is our finder. On node with text, yeah, that's finding what we're trying to test. But yet I cannot find that property, use unmerged node. Okay. All right, let's just keep going. See, in this step, you learn how to debug this using the semantics tree. Okay, semantics tree. Compose tests use a structure called the semantics tree to look for elements on the screen and read their properties. This is the structure that accessibility services use as well, as they're meant to be read by a service such as TalkBack. Okay, warning, layout inspector support for semantics property is not yet available. Interesting. Okay, you can print the semantics tree using the print log function on a node. Add a new line to the test. Okay, we gotta add a new line, and this will log out some hopefully interesting stuff. Okay. Okay, so all right. Okay, add that new line. Now run the test and check out Logcat in Android Studio. You can look for current label exists. Okay, so run this. We're gonna run it, and then we gotta go to Logcat. I changed this to rally test, and it says look for something specific. You can look for current label exists. Oh, that's where, yeah, it's printed. Okay. Did I do the right one? Maybe it's this one? Maybe it's not. I am not finding it. What am I doing wrong here? It's a debug. Okay. Okay, I had to do no filters. Okay. Let's open this up a little bit. And it says current label exists. All right, what do we look for after this? Okay, there's the output. Hopefully now you understand the convenience of isolation. The semantics tree of a full app would be very long. Okay, warning, composables don't have IDs, and you can't use the node numbers shown in the tree to match them. If matching a node with its semantics properties is impractical or impossible, you can use the test tag modifier with the has test tag matcher as a last resort. Take a look at the semantics tree. You can see there is a selectable group with 3 child elements. Let's look for that. Selectable group with 3 child elements. Selectable group, okay. With 3 child elements. I'm wondering if it's this, node 1, node 2, and node 3. They all seem to have the same properties. L, length is 0, T, or L is 0, T is 171, R is 1080, B 325. I'm really not sure how to read all this. Am I doing the right one? Maybe. Okay, let's just keep going. Okay, which are the tabs of the top app bar? Turns out there is no text property with the value accounts, and this is why the test fails. However, there is a content description for each tab. You can check how this property is set in the Rally tab composable inside top app bar Kotlin file. So we need to see how the content description for each tab is set inside that Rally top app bar. Let's look at it. I don't see, let's see, Rally top app bar. I don't see a content description. Let me look. Okay, here it is. Content is there. Clear and set semantics. There we go. Content description equals text. Okay, so on that row, that's where it's set. Interesting. Okay. So that's how it's set. It's on this row composable, which is inside of a Rally tab. And there's a Rally tab for each group. All right, I see that now. Cool. This modifier is clearing the properties from descendants and setting its own content description. So that's why you see accounts and not accounts, all capitalized. Replace the finder on node with text with on node with content description and run the test again. All right, let's go back to the test and we'll do on node with content description. And it says run the test again and we should be golden. All right. Congratulations, you fixed the test and learned about the Compose test rule, testing and isolation, finders, assertions, and debugging with the semantics tree. I still don't understand this quite fully. And the test failed, so that's not really. Was there something else that needed to change here? Okay, we don't need to do it all in uppercase. Okay, it's just accounts.name. Okay, so get rid of this uppercase. Okay, now let's run it again. And I cleared the Logcat before running it. Okay, the test passed. Let's look at this logcat a little bit. Let's see. Printing with use unmerged tree equals false. Okay, node 1, node 2, node 3, selectable group, node 4, role equals tab, focused, false, selected false, content description, overview, actions on click, merge descendants true, clear and set semantics true. Okay, so it kind of like, it shows each thing at its depth too. But it gets confusing because it goes from 4 to 8 to 13. Okay, I feel like this is just something you gotta play around with a while. And let's keep going. Okay, it says bad news though. This test is not very useful. If you look at the semantics tree closely, the content descriptions of all 3 tabs are there whether or not their tab is selected. We must go deeper. Merged and unmerged semantics trees. All right, the semantics tree always tries to be as compact as possible, showing only the information that's relevant. For example, top app bar, there is no need for the icons and labels to be different nodes. Take a look at the overview node. Okay, this is the overview node. Is that what we got here? The overview node? I believe it is. Okay. This node has properties such as selected and role that are defined specifically for a selectable component and the content description for the whole tab. These are high-level properties, very useful for simple tests. Details about the icon or text would be redundant, so they're not shown. Compose exposes these semantics properties automatically in some composables such as text. You can also customize and merge them to represent a single component made up of one or multiple descendants. For example, you can represent a button containing a text composable. The property merge descendants equals true is telling us that this node has descendants, but they've been merged into it. Okay. In tests, we oftentimes need to access all nodes. In order to verify that the text inside the tab is displayed or not, we can query the unmerged semantics tree, passing use unmerged tree equals true on the root finder. I see. Okay. So is this the same test? Current label exists. Okay, so it's in here. All right. And then we don't do, it says not to do the assertion. So let me just comment this out and go ahead and run it. Okay. The output in Logcat is slightly longer now. Oh, I can kind of see it now. Node 3, it's the tab overview, this one, tab accounts, and then there should be another one, tab, yep, is bills. I can see that now. Let me verify here in my local one. Okay, did it, let's see, accounts, bills, and overview. Wait, is this the same one? Okay, yeah, use unmerged tree is true, so it's everything below. So let's see, selectable group, role tab, content description overview. Where's the other one? Content description accounts, content description bills. Let's see the previous one. It was similar, but there's a lot less, you see? This is the old one before they were merged. And this is the new one after they're merged. There's a bit more. Okay. Okay, let's see. Node 3 still has no descendants. Node 3, okay. Here's node 3, no descendants. But node 6, the selected tab has 1, and we can now see the text property. Yep, selected equals true. It has the text property. Okay. In order to verify the correct behavior as we wanted, you'll write a matcher that finds one node with the text accounts whose parent is a node with the content description accounts. Check the Compose testing cheat sheet and try to find a way to write that matcher. All right. I mean, we're going to have to use on node with content description and has text, I'm guessing. We're going to have to use both of those. I'm not sure. Note that you can also use Boolean operators such as and or with matchers. All finders have a parameter called use unmerged tree. Set it to true to use the unmerged tree. Try to write the test without looking at the solution. I'm not going to do that. I'm just going to look at the solution. Oh, excuse me. Okay. Okay, so we're has a parent. Oh, I didn't see the has a parent. Oh, there we go. Has parent and on node with content description, I'm guessing. Oops. Let me go back to that. So yeah, has parent and has content description. I see. So we're going to use both those. And has text. Okay. Let's grab all this. Paste it there. Uncomment that. Okay. So let's see. Compose test rule. I'm going to format this. There we go. On node that has text. Okay, it's that enum. And we put it all to uppercase. And has parent. And that parent has content description. The name of that enum, which is accounts. Use unmerged tree, set to true. Let's go ahead and run this. Note in this case, strictly, you don't have to add the parent to the matcher because it's a very isolated test. However, it's a good idea to avoid using broad finders alone, such as has text, which might fail in larger tests when other instances of the text might be found. Go ahead and run it. Congratulations. In this step, you learned about property merging and merged and unmerged semantics trees. Excellent. It passed. Okay. Go to the next one. All right, synchronization. Any test that you write must be properly synchronized with the subject under test. For example, when you use a finder such as on node with text, the test waits until the app is idle before querying the semantics tree. Without synchronization, tests could look for elements before they're displayed, or they could wait unnecessarily. This is kind of like with data binding. We'll use the overview screen for this step, which looks like this when you run the app. I remember that, we did that. Okay, note that the repeating flashing animation of alerts card, drawing attention to this element. Create another test called overview screen test and add the following content. Okay, so we got to create another test class called overview screen test. I assume in the same place right here. New. That's a class. We're gonna add that to Git. I'm gonna minimize that. Okay, and add the following content. Okay, let's grab all this. All right, let's see this. Compose rule. Okay, the test is overview screen alerts displayed. That alert, I think, is that flashing. Compose test rule. Set the content. It's this overview body. Let me hide that. Overview body is, it's a column and it has that alert card, spacer, accounts card, spacer, bills card. Okay, so that's like the whole overview screen. I got it. All right, and then compose test rule on node with text alerts. The cert is displayed. All right. If you run the test, you'll notice it never finishes. It times out after 30 seconds. I'm gonna go ahead and run it and be patient for 30 seconds. I'll try to at least. Okay, the error says resource timed out, possibly due to Compose being busy. Idling resource registry has the following idling resources registered. Busy, it's a JUnit 4 counting idling resource. Okay, this is basically telling you that Compose is permanently busy, so there is no way to synchronize the app with the test. You might already have guessed that the problem is the infinite flashing animation. The app is never idle, so the test can't continue. Let's look at the implementation of the infinite animation. All right, overview screen Kotlin file. Let's have a look at that one. Overview screen, where is that? Overview. Actually, let's look at the test. Yep, that's exactly what we thought. Okay, let's look at we gotta look at the overview screen right here, Kotlin file. Oh, we are looking at that. Where does it actually show the oh, there it is. Is this the one we're supposed to look at, the alert card? Current target elevation. Let me see if I can find that. Current target right here. All right, mutable state of 1DP, launched effect, current target elevation, start the animation, animated elevation, animate DP as state, target value, animation spec tween, 500 milliseconds, finished listener. So it looks like it just interpolates between 1 and 8. And then it uses that in this card. Yeah, it uses that in animation in this card. This card is a column, has a header, show dialog equals true, alert header, rally divider, and then an alert item, the message. Okay. All right, this code is essentially waiting for an animation to finish listener, and then runs it again. One approach to fix this test would be to disable animations in developer options. It's one of the widely accepted ways of dealing with it in the view world. In Compose, the animation APIs were designed with testability in mind, so the problem can be fixed by using the correct API. Instead of restarting the animate DPS as state animation, we can use infinite animations. Infinite animations are a special case that Compose test understands, so they're not going to keep the test busy. Replace the code in the overview screen with the proper API. So card, what is card get? Card gets animated Okay, so we gotta replace all that. I forgot this as well. It doesn't use the value. Let me just keep this separate. Okay, so we're changing this on the card. Infinite. Okay, animated elevation. So we're adding this infinite. Remember, we're importing that. Remember infinite transition. And then what's different here? Animated elevation. DP. Let me import that. Okay. So I imported some things. Let's see. This is of type DP by, it's a delegate, infinite, elevation, animation, animate value. So initial value, target value, type converter, it's vector converter. What is that? Two-way converter. Okay. Animation spec, infinite repeatable. Repeat mode reverse. Okay, so let me first delete this. Okay, that's gonna change there. We're gonna use that, and then we get rid of all this. Okay, so we corrected our animation. So, I mean, really, if the previous way shouldn't be used at all if you want to make testable UIs. Kind of be better to just get rid of that and not even allow it. Just to see, you know, you're not allowed to do something that's bad. Now let's run this. Okay, we learned about synchronization and how animations can affect tests. Oh, we're still failing. Why? It didn't even run. Is assigned but never accessed. Oh, I think we can get rid of that as well. Let me try again. It's taking longer, so it looks like it's doing something. All right, there it's finally running. Okay, I saw it flash. Awesome, it passed. Excellent. All right, congratulations. You learned about synchronization, how animations affect tests. Next one. Optional exercise. In this step, you'll use an action to verify that clicking on different tabs of the Rally top app bar changes the selection. Hints. Okay, the scope of the test to include the state, which is owned by Rally. Okay. Verify state, not behavior. Use assertions on the state of the UI instead of relying on which objects have been called and how. There's no provided solution for this exercise. So let's just, you know what, let's just do this. We'll just check out that branch that has it. And check out. We're going to force checkout. And that was on, I believe, the overview, right? No? Or was it? Where was it? Oh, they don't actually write that test for you? It's there's no provided solution for this exercise, not even in the end. That kind of sucks. Well, how do you know you got it right? Okay. All right. Well, I'm not gonna go through it. Yeah, that's so that's testing in Compose. And there's lots of other samples here you can see, it looks like, on how to test. Oh, very cool. Lots of free code to get started with Compose. I like it. Awesome. So very cool. This is a codelab on how to test Compose stuff. Hope you enjoyed it. Like the video, subscribe, and I'll see you in the next one.